So again, thank you very much for joining us this evening. The second part of our call this evening is now about computer coding. And we're kind of picking up where we were in December. We can just take a little review as to what we did leading up until our holidays. So our mentor session just finished, and here's our Java session, January and February sessions. This one's starting at 8 o'clock this evening. And last time we took a look at a timed robot, a drive subsystem, how to do sensors, and how to do actuators. And we looked into the FRC robotic simulator. So the purpose of this evening is to welcome any new participants, is also to review some of the things that we did before we broke for the holidays, and to answer any questions that you may have, as that will help us to plan the additional sessions between now and the end of February. We're very much community driven. If there are questions or suggested topics, we're very happy to incorporate them into our sessions. So this is kind of a reflection, planning, feedback, suggestions kind of a session. Please feel free to ask questions in the chat. Every few minutes, I'll see if I can follow up on them. And we will, kind of plan together our community's time with coding between now and the end of February. And based on what you see this evening, then we will, or based on your feedback this evening, this will help us to refine our plan. So our schedule right now, based on discussions with various individuals and suggestions received from the community, we're looking at just doing a little review this evening, but in the subsequent sessions, perhaps 2 weeks on PID, which is a common approach to getting precise and smooth action in a arm of a robot, for example, or some other device that's moving on a robot. State machines, which is a set of steps that can be taken one by one, each with a starting condition and an ending condition to achieve a certain outcome on a robot assembly. For example, in the 2018 sort of infinite recharge, was that one? Oh, wait a moment. The video
2018 was Power Up.
Yes, Power Up. Sorry, time is going so quickly. The Power Up game, our team had a state machine. We would press a button and our pneumatic arm would open. It would move down slightly, grab one of the milk crates, and then move up and get ready for a sort of a slam dunk into the scale. And that was done using state machines, and that was really helpful for us. And our state machines were integrating encoders, motors, sprockets and chains, sensors, and the like to achieve their functionality. And then robot vision is really a very popular and yet challenging sort of topic. There are various approaches to robot vision. You can get some pre-made solutions, which are very quick. And then there are other ways to do vision, which are much more technically challenging, and depends on the objectives of your team, what you would like to learn. Both are available, and we'll provide some examples that can be used for both an easy beginner kind of approach to vision or a more advanced and technical approach to vision. And of course, other topics as requested by the participants in our sessions here. So that is our plan. Let's just take a look at the chat and see where we're at. So okay, I'm just responding to the chat. A message, direct message about joining a team. There we go. There was no session last week. This is our first planned session for after the holidays. So yeah, we're just now starting fresh. Are there any other topics that are not listed here that the community would like to discuss in upcoming weeks? We'd be very glad to include them. So please include that in the chat. And if not, we'll just take a look at a little review of some of the things that we were doing up to the holiday time. Just going to stop share and share another file here. Okay, so here's a Visual Studio Code. It's on my desktop here. And when I click on it, it will bring up a version of Visual Studio Code, which is provided by the FRC sort of website. Let's just take a look at that. FRC Robotics Competition Control System. This is part of the FRC game manual. Oh, sorry, no, that's another link. Sorry. This is just on wpilib.org, Worcester Polytechnic Institute Library, which is a library of computer coding modules and the like used for FRC programming. So we have a question coming up about command-based, and that will be excellent. We'll address that in just a few moments here. We can take a look at the comparison between the command-based and the sort of basic approach to robot programming here in just a few moments. It may be a very good idea to read through here. It's been updated. And every year when there are updates, often you will find that the software base that you may have been using has also been updated, and you have to be very careful. This is a good thing worth, oh yeah, so Ryan has just pointed out the 2022 version of the WPI lib VS Code has come out. So you want to do an update. If you do update though, you must be cautious in case they have updated some of the commands. This may cause some of your previous code not to work. So just use caution when updating. And there's a download link. Thank you very much, Ryan. And so let's just take a look at this. I'm going to click on that. And here's the kickoff release of WPI Lib for the 2022 season. There's the documentation here. There's a getting started link for those who are new. And what's new for 2022 is good for a review here. So this might be a good thing for us to do for next week, that we'll go through the exercise of following what's here in the WPI Lib 2022 and maybe installing that for our next few sessions, because that will be much more useful than using the previous version that we were using before the holiday. Known issues are very good here. What's new will tell you maybe some commands that may have changed, and there's the WPI Lib installation guide and game tools. So a great exercise for everyone to install the new software base. We're not going to do that tonight. If we do get requests next week about technical issues that have arisen, then we will be very glad to cover that in next week's session. So this is a good set of homework for everyone to get prepared on their systems with the WPI Lib 2022 and the VS Code and get everything working. So that's probably the first thing we'll do, and maybe we'll explore a little bit about the WPI Lib 2022 and see if there's anything new for us in our time next week. So there you'll find for Linux, Mac, and Windows. And there will be instructions for each of them here on how to install them. So follow those and continue working with your VS Code in that way. So now let's just talk a little bit about command-based coding, and I will do this at the risk of having something slightly different in the 2022 season. Even so, the general idea of the command-based coding is probably going to remain the same. So I can't speak from experience. I haven't used the new 2022 season software yet. So let's just go to our VS Code here. And a little nice review, this sort of side panel here is where a lot of important features happen. If you get lost, going back to the documents here, that's your robot code. There's your GitHub initialization and updating to the online repository GitHub, and so on. We went through the sort of interface in an earlier session between October and present. And you can find these on the YouTube channel, the First Robotics Canada YouTube channel, Java coding sessions sort of playlist. So anyway, I'm going to use our shortcut we discussed last time. The Control Shift and P gives you options. And what I would like to do now, I'm going to create a new project. There it is here. If it's not listed, you can just type in something like create and it will start listing that. There it is, for example. Oh, one moment. Okay, so create, and there is create a new project, and so on and so on. So I'm going to choose WPI lib create a new project, not Java create a new project. And here we are selecting a project type. And again, just a grain of salt, maybe this has changed by now. The exact selections may have changed now, but the general idea should be the same. I'm going to select a project type. First, I'm going to select a sort of a timed robot from a template, Java template, timed robot. And I'll select a base robot folder. So I'm going to call this timed January 2022. There we go. And there's a base folder. And the project name will be timed January 2022 project. And my team number, I just default to my old team number. And I don't need a desktop support. I'm not going to do a simulation, so I'm not going to click this. I could, but I'm not. I'm just going to generate this project, and yes, in the current window, opening this project. Okay, so where is everything? The left-hand side here in the Explorer, we have the file systems under the source directory and Java. We have just 2 files. So that's one important thing to consider for the timed robot. It's a simpler file structure. And then we go into here, most of your robot code is going to end up in one file. So in some years, my team has elected to go with a timed robot. In other years, it's elected to go with a command-based robot. And there are a few reasons why you would do one or the other. Definitely, to begin, a timed robot is easier to understand. The drawback of the timed robot is it's a little more difficult to collaborate unless you're using something like GitHub, because all the functionality is coming from one file. So say you have a programming team of 4 programmers, well, they have to get in line to edit the file, and they have to coordinate that and hope that updates to the file don't step on the toes of other updates to the file, as we talked about in our discussion of GitHub and online repositories of code and the like. All right, so the timed robot in that case is very relatively simple, and yet the drawback is collaboration is a little bit more difficult. So there's our timed robot. Let's now go to our command-based robot, Control Shift and P, create a new project. And I'm going to go here, selecting a project type, a template again, and CPP. There was, oh, sorry, I said CPP because I saw in the commentary the team decided to go with C++. And And for every function in WPI-lib in Java, there's a similar one in C++, and the documentation is all sort of parallel in that regard. And I suppose the examples are about the same. Like, for example, if I go here, the C++ also offers me the same kind of selections as the Java. But let me just try that again. I'm going to go back to template and Java, not C++. And this time a command robot. Oh, there's the old command style. It's deprecated, so maybe going with the new command style. And base folder, I'll call this command January 22. And there it is. Oops. Put my team number here. And I'm not going to enable desktop support, just generate the project. Oops, it wants to actually make a new path here. So let me just go back here and make a new folder. Maybe it will like that. There, now it has the new folder, and let's go to generate the project. Again, our Explorer has the files, numerous files here. Some of them are for configuration and for settings and things like this, and our build system. And one thing we look at here is the source. So now we still have the source folder, but now there's a subfolder in Java for commands and a subfolder for subsystems. And there are 4 main files in our subsystem or our Java folder. Let's look at each one. We'll start with main, as that's the main one. Interesting here, not a whole lot happens in main. It just calls a new instance of the robot base start robot. Using start robot, it just starts up a new robot. And it gives you a few warnings. Don't add any static variables here, and gives you just a little bit of guidance. Basically, you don't need to do anything with this file at all. Let's go to our robot.java. And here's a new thing that happens. When we start up a robot, all we do is start up a robot container. So what are we doing? Just starting new files or new instances of objects with each one. So we started up a robot. Now the robot's starting up a robot container. And not a whole lot is happening here. It's just getting us very much a basic start. There's a little bit of code for the initialization of the autonomous, giving us possible commands that are in the system, and not a whole lot happening here. Okay, now the robot container. Let's see what's happening here. This is where we're going to start getting the action going on in the command system, and we're going to define our hardware, and in this case, commands and subsystems. So there is an example subsystem in here and an example command. So we have a bit more of a hierarchical structure in the command-based robot. We have subsystems and commands, and we'll explore a little in the subfolder here in a moment. And looking through here, our robot container, it invokes a new subsystem and a new command, and does a little bit of setting up. I don't think it's worth going into the full details at the moment. We're going for a high-level overview. And let's see what the commands and subsystems are looking like now. So the robot container is now coordinating commands and subsystems. I'm going to start with the subsystems here. So here is an example subsystem, and it's extending a base class called subsystem base, and there's a periodic and a simulation periodic method listed in here, and nothing's happening. A subsystem, well, the way we used it on my previous robot, we had one subsystem just for the drive base, which consisted of basically 4 motors and a few other details like encoders that went with those motors. And that was in our sample subsystem 1. And then we had another subsystem for the ball collector. And then a third subsystem for the, what was the third one? Oh yeah, for the climb. So the ball collector and shooter, and for the climb, this was a few years ago when we used that system. And similarly, in the 2020 season, we had our subsystems divided up like that. The base and 3 other subsystems were put together in that way. Okay, so a subsystem is like an assembly of actuators and sensors on your robot that have related functionality, say like the motors and encoders on your drive base. But a command is a set of actions that can be taken by that subsystem. Let's look at in the command here. In the command, we define a new subsystem and we declare what it depends on. I haven't used that in a little while, have to review that. And in here we have command sort of samples for initializing and executing within that command, for example. So I do have some sample code that we can go through in a future session to go through some more detail. But this is just a tour of the basic files, and we can explore a little bit later how they go together. I may want to take a little time to look at this year's command-based framework to see if there are any significant changes, because the first time that we implemented these command-based code bases, we ran into a little bit of a difficulty because some of the documentation was referring to old deprecated commands, and it took us a while to figure out that that was preventing our code from executing. So once again, since this is a new season, update and just be very careful that if you get some YouTube video telling you about a command, make sure that command is still valid in the WPI-lib system that you're using. So there we are, good. That's a little bit of a kind of a review of the timed robot and the command-based robot, both of which are choices for teams that will equally run the robot. Each has its advantages. The command and subsystem sort of division here would allow, for example, one programming student or team to program a subsystem for the drive base, and another one to program a subsystem for the shooter or for the collector or for the climber, for example. So it allows for collaboration a little bit more naturally, unless you're very systematic about it in your single file time system robot. The only sort of drawback is it's a little more complex, and it can be a little challenging to troubleshoot, especially if you encounter old commands in a new framework. There we are. Okay, we'll go to open a new project here, or a previously created project. And looking here, we have a motor controller example. I think that's a good one to go with. So we generated this file before the holidays. And let's take a look at what we have in here. There is a motor controller, a Spark Max. But what if you had a different motor controller that you were using with your team and you were maybe going to adapt this code to use on your team? What might you do? So there's the question of the hour, how to use a different motor controller. Well, first of all, you have to find out what is it named inside of the VS Code system. Okay, so now we have got a PWM Spark. Well, let's try some other ones. PWM. Oh, there we are. We've got Talon FX, Talon SRX, PWM Venom, and Victor SPX. Those are some choices for a pulse width modulation motor controller. We've got numerous ones now. They're gradually accumulating in our code base here. So you may choose one of those corresponding to one that you have. It is possible that you may have a CAN bus. Interesting, it's not coming up here.
It's probably like can, and then you need to say can and then dot something else.
Ah, that's it. Okay. So in that case, I've forgotten how to access the cans. Maybe we can look it up.
I think it's just Spark Max. I believe that all the CAN bus ones are the defaults. So you just do .spark max. It should
Oh, okay, that's nice. Oh, there we are, Victor and Victor SP. Thank you for that reminder. So there's a WP iLibJ Victor, it's just a standard one. And according to our commentary here, so I'm not so sure about this, but our suggestion here is that it's a CAN-based motor controller.
Can you talk about like what if the like motor controller that you need is like not located inside of Visual Studio, but you need to like import it from like a website?
Exactly. And that's where I was getting at. I was thinking of the CTRE, Cross the Road Electronics devices, and they have a special software sort of download. So that's what we used to have to do. So let's go, for example, to the Cross the Roads Electronics website and look at the instructions for adding one of their motor controller libraries into VS Code. So I'm just going to go here to, and I remember we used to use Talon. So there's a CTR across the road electronics Talon SRX. Oops, sorry about that. And in our overview and technical specifications, somewhere on this page, we should be able to find a link to the required downloads and things like this. Software and downloads, software and firmware. So it's not associated with the product, as in some sites, it's up here, software and downloads. Let's go to our software and firmware.
I believe it is like if you go back, I believe
Okay.
I believe like the link was like right beside go up. Do you see
Here
where
we
it
are.
says software
Whoops.
and hardware user manual?
Oh, thank you. Missed that. Okay, so hardware user manual and software. Okay, so it's good to download that and read through it carefully. And the firmware is one thing, and the software. A lot of this has to sort of fit together. I'm going to go to the software. Oh, it's bringing us here to the Phoenix Framework software. The Phoenix Framework software is a separate set of software that we use on our robot to let the robot set and understand the addresses of all our motor controllers that come from Across the Road Electronics. So There are older versions here. And maybe if you have some older versions of the hardware, you may need the older software, for example, and you can probably find them here. And there's some more in the WPI lib documentation. The Phoenix framework installer is the first thing you need to get going. And so you download and install that. So there's a whole process that you'll have to go through to make that work. And make sure that each one of your motor controllers has an address on the CAN bus, and it's a unique address and it's not conflicting with any other device on the CAN bus. And so let's see here. There is something for inclusion in the VS Code. The free, it may be that we actually just have to do that from the VS Code. I'm sort of recalling very slowly here the process we went through. These are the things you do like once a year and then forget how to do them. So a common thing that you will encounter just sort of researching and finding out the right set of steps to get something done. So we need to find a way to integrate something from across the road electronics in our VS Code. I was expecting to see it here. It may be in our documentation. I don't want to go too far down a rabbit hole, but maybe I might look here or do a few more clicks. But just from the other side, there are ways to install some vendor dependencies here. And this is where they're going to appear. Or there is a way to do that through the command palette. Add a dependency, for example. Manage vendor libraries. So check install new libraries online or offline. What if I tried online? Then you enter a URL for a file. So that's what I'm looking for. I'm looking for an address where I can get a vendor library for, say, something from across the road electronics. Here we are. Maybe we can find it here. There's nothing about vendors here, is there? So I'm going to try just a general Google search.
I actually remember doing this in the off season because I was like kind of curious, but I kind of forgot about how to do it.
And it's the same. If you only do things once a year, it's very easy to forget. And sometimes they'll change the interface anyway. Oh, third-party libraries. Here we are. So here's a good part here that's going to tell us how to do that. I'm going to put this in the chat. So yeah, with a little patience, we can usually find what we're getting. And I tried on one website, I tried on the actual software, and finally Google knew everything. And there's a set of instructions here for managing the VS Code libraries. And check to install these libraries. Okay. And here we are, CTRE framework and all of the things here. So maybe I actually have to install the Phoenix framework for all of these library dependencies to come out. Good, so that's how we're going to go about installing the particular libraries for some of these motor controllers. And just pay attention, I know for sure CTRE, Talons, and Victors need these, but there may be other motor controllers that need them. I'm not sure, I haven't used a lot of the other controllers. Okay, I think that's probably as far as we should go here. This will point you in the right direction and get you started, and be very happy to do some troubleshooting with Teams. If you get that to the point and you want to try getting that working, you basically follow the instructions for your particular motor controller here, and then install your vendor library in VS Code. So there we are here. Going back here then. So not only do we have to install, we also may have to install the vendor dependencies for certain hardware products that we're using. So right now I was imagining using a Victor, and it's giving me a sort of an underline. The reason is I haven't made any reference to this Victor anywhere else in the program, so it's unused. So to get rid of that one, I have to go down in my code and make a new example of the Victor. I already have, which one here, a Spark Max. So I'm just going to call this sample motor. And let's just imagine it's on channel 2, for example. Okay. I'm going to need to specify, well, what is my sample motor? So I look at my M motor here. Where did I specify that? That's a speed controller. So
Did you successfully get the vendor file from the vendor?
I didn't, because I think it's something I would like to prepare first so it goes smoothly. I was showing the general place that we do that, because it is possible it could take 30 seconds or half an hour.
I think I found like a YouTube, I believe I have a YouTube video which they tell us how to do this process.
Oh, excellent. Maybe you can share the link with us, and
I'm not sure like which exact one it is, but I know that it's like one of 4.
Okay. Do you have a suggested channel on YouTube that we might check out?
Basically, like the one that I was like watching is like by OCS Robotics. I could
Okay.
send like the link to the YouTube. I believe like this one is the one where they talk about it. It's either this one or the third one of the series that they talk about like how to get the vendor files.
The
So like how to do like I sent the link to like the YouTube video.
Oh yeah, here it is. Okay. Just take a look there. Nice. So PI-lib VS Code introduction. And so there, that's something that we can have everyone take a look at and see if that will help us. There's a whole set of videos like this. Sorry. I'm just taking a look there. And yeah, so everyone can explore that and see if that will answer the question about installing the vendor dependencies. And if so, that's good. And otherwise, I'll be very glad to prepare that for next time. I just don't want to take up too much time here. I'm just sort of gauging everyone's general questions for the whole series of our sessions here. All right, so there we are installing a new Victor, and then at some point during our teleop, we can maybe just tell the motor to run. And now we have 3 references to sample motor, telling the program at the very beginning of the class that we're going to use a Victor motor controller, and we're going to call it sample motor, and then initiating or instantiating a sample motor as a Victor on channel 2. And then finally, this is probably not recommended in practice, just setting it to 100% and leaving it there. And that's not a good practice, but it's technically possible. You wouldn't want to just run a motor full speed your whole match, but that's what this does. And that's the general process of connecting hardware to software. We identify the library that's required. We're going to have to install vendor dependencies for certain items of this software. And in the case of CAN bus devices, use our Phoenix tuner software, which was pointed out earlier, to set a channel for each of the devices carefully so that there's no overlap. And then finally, once you've defined these devices in your software and initialize them on a certain channel, then you can make reference to them in your robot program. That's the overall process. The details are suggested here in this YouTube video and on the CTRE website and on this page here, the third-party libraries page will be very helpful for you to set up CAN bus related hardware on your system. There's another link to a YouTube
I posted
video.
the wrong one.
Okay. Oh, thank you, Ryan.
I thought it was like the second one of the series, was actually the first part of the series.
Oops, that works. Okay. So there's your new YouTube link that talks about installing the motors from the CTRE website. That's great. So hopefully that'll be a challenge for everyone to try installing that, especially if your team has access to CAN bus related devices. That will be very helpful for you. Okay, so just looking back here. We just did a little bit of a review of what we did before. We addressed a few questions about, for example, installing vendor dependencies. We have, 3 suggested topics for the next 6 weeks. PID, which is smooth operation, using calculus to smoothly operate robot actuators, state machines, and then vision, and of course, other topics as requested. So with that, we have had a sort of a, okay, so there's a question about the CAN bus. So very glad to do that. And there's a nice opportunity to also direct everyone to the previous sessions. I'm just going to pull up a link to our YouTube channel. And our playlist. The Java coding playlist is here.
My job
Oh,
is
so
to
sorry.
make
Lots of advertisements all the time. And here comes a link to our playlist. Coding session 1 from October 19th is there. The playlist link is here. And there are a number of topics here covering the very introduction of Java and moving up through several topics. The last few sessions, we were doing things like discussing the significance of the CAN bus and how to do a timed robot, how to do a robot simulation. We also had on December 6th, we had our coding cooperation, which was a summary of the first few sessions of coding, sort of celebrated in a little competition between autonomous methods written by various participants. And it was written in Java FX, which is also referenced in our coding sessions. Java FX can be used as a good means of creating a custom graphical user interface for your robot. And that's why the game for our cooperation to consolidate our Java skills was also written in JavaFX so that teams may use the code as an example to extend into using on their robot systems, or driver station, for example. Now, each of these sessions, not the first one, I believe, but on subsequent session, there should be links in the descriptions here. See if I can find the description. There we are. There are links to the slideshow and any other significant references made in the sessions or associated files. And then, of course, there are some time codes. So you don't have to watch all of each session, just focus in on what you're interested in. So there we were doing the timed robot, Git integration, and so on and so on.
I have a question.
Sure.
So basically, I got a Rami robot from like the Polulu place.
Yeah.
And like basically, like when I'm trying to run it, like when I'm trying to run it, like the wheels don't actually move for some reason, and I'm not sure like why it does that. Like basically like the actual like dashboard updates with like updates like when you press like the buttons, but the wheels don't actually move.
So that's a really good practical question, and it could be hardware or software or both that are the issue here. So that would be a good thing to discuss. I just wanted to take a little moment to just give a brief reference to the CAN bus. I know we kind of covered it last time, but in short, the CAN bus is a set of two wires, yellow and green, that connect together multiple motor controllers and other actuators on a FRC robot and in other industrial applications that allow many devices to use one physical plug-in. In this case, the wires start at the Roborio, move through the motor controllers and perhaps the pneumatic system, and then end at your power distribution panel. And they allow you to get more actuators than would be otherwise possible using just the channels for the pulse width modulation that come with the Roborio. So the CAN bus gives you the possibility to use more motors on your robot, and so therefore it's quite desirable. We were forced into using it after our first season. We just started to run out of motors, and then we got into the CAN bus as a result. The previous sessions have some reference to the CAN bus, and I'd be also glad to cover a few other CAN bus examples as we go through. So hopefully that will at least partially answer. So now, as for the Romy question, this is a very good troubleshooting question. It might be a good way to summarize our evening. Is there a way that you might show us the code that you have for your Romy? Maybe we...
It is basically just like like I was watching like a YouTube tutorial on it, and basically like one person got it working by just using like the base code of the Rami, which is basically if I just click Control-Shift-P and I say create a new project.
Yeah.
And then like I do like, and then I would click example, Java, and then I would go all the way to Rami reference. That is the one that I was using, just like the base Rami reference code.
So the fact that another individual got the Romy sort of working with the default code suggests that there may be a hardware issue. Possibly.
Yeah.
Or now what's another thing is the driver station program. Do you actually use the driver station? Because sometimes it's not entering your team number, not having the right channel for your game controller, or something subtle like that, or the battery, or it could be if you're using a Raspberry Pi, which is the sort of brains of the Romy. There are all kinds of little pins on a Raspberry Pi, and if one of those is not pinned in properly, or if it's not powered correctly, so it could be you need to double check your connections. So every single piece has to be in order. Your Raspberry Pi has to be powered up with enough power and with no shorts in it, and the correct pins have to be connected into the system. The Raspberry Pi has to have the correct firmware in it. So if you've uploaded your firmware, or sorry, if you uploaded your Romy code into your Romy successfully and it gave you a success message, that's a good sign.
It gave me a success message.
Good. So then that suggests that your Raspberry Pi is working and it's probably connected up correctly. You may also want to just check that the motors on your Romy have been correctly plugged into the right slots, because you may have the exact correct code, but it's in the wrong channel. And so you may have to do a slide.
Should I turn on my camera and show you my
Sure.
robot?
That'd be interesting just to take a look. I've never actually used a Romy, but I'm just using the sort of the thinking process we developed through experience with the FRC robots.
So basically, this is it. Like,
okay, that's good. And there's the Raspberry Pi in the center there. Now, each of the motors plugs in, I would guess, to some kind of motor controller, which somehow connects eventually back to the board. Is that right?
Like basically, like the instructions just told me to connect like the motors, like these are the motors over here.
Yeah.
Like, and like basically like that's like what the instructions told me to do. Like when building it, it told me to like connect the motors right over, like right there.
And the Raspberry Pi, it probably plugs into a set of pins on the board, doesn't it? Or the pins on the Raspberry Pi plug into the board. Is that right?
I think so, right? I think so, but I cannot really see like under the Raspberry Pi very well.
So the fact that it uploaded suggests that it's probably powered correctly. The one thing that came to mind, having used a lot of Arduinos, is to make sure that the pins are correctly lined up exactly, because there are lots of pins and sometimes you can be off by one pin. I don't think that would be the case. And that everything is plugged in correctly. So you may want to just double check the construction of the Romy, however much you put it together, and make sure every single connection was done correctly. Now the channels, do you have a sense as to which channels are being used by the motors on the Romy?
What do you mean by channels?
Well, do you have a way of like sharing your code? Or maybe I could just pull up the default Romy code. I would assume it's similar. Because
it is just a default Romy code. I did not change anything.
Okay, we'll take a look there and explore some possibilities from the software side as to what might be going on. So let's just pull up a new project, in this case, a Romy project. So template in Java for a Romy.
It was example. It was an example.
Oh, it was an example. Ah, there we go. Okay. So the fact that you're using an example suggests to me it may not be complete. Maybe you can tell me which example was it?
So if you click example Java,
yeah,
it was Romy. It was called Romy reference.
Okay.
It was all the way at the bottom.
Oh, it's at the bottom. Here it is.
That is the one.
Okay. Okay. Now let's take a look at the source. Whoops. And it was a command-based. Whoa, okay. So onboard IO, those look particular to a Romy. Okay, do you have a game controller?
Yes, I do.
And is it on channel 0 in your drive station?
Yeah, I think so.
So that is a very important sort of thing. And have you entered your team number in your drive station?
Oh wait, I like the thing that I was using to like control it is basically like when you run it, like the thing that just like pops up. I'm not sure if like I believe like it was just the thing that pops up after like you run the program. Like
okay, so
you know,
maybe
like when
that's
we
how...
were doing the simulation like
Ah,
another
okay.
screen popped up. That was the screen that I was using.
Okay, so when I did that with the simulator, I still had to do a little bit of connecting together in that, for example, I had to connect together the keyboard with the correct channel so that the right keys were being used. So that is a possibility. So there's one place there to make sure your game controller is in the right channel. That let's just go down through here and see some other things that could be happening. One of the subsystems I would guess is the drivetrain. There we go. Oh, it says Spark. Interesting. Romi gyro. Okay. So there's where the channels are. There are channels 0 and 1, and there's the encoders in 4, 5, 6, and 7. But these ones here are going to be important to make sure that they're plugged in the right channel on your Romi. But as you said, you've constructed it according to instructions. It should just work.
Yeah, I've constructed it in like from like basically the instructions that I followed were on the WPI lib website.
Nice. And what kind of power source does it have? It's like a 9-volt battery or something?
It is AA batteries.
Oh, AA batteries. Okay. And as long as they're put in, and you're obviously getting power to the unit, so that's fine. So is it possible for you to share your screen, what you're showing when you actually try to control the Romi?
Sure. Just going to get back to my project. Let's see. One thing which I was thinking of is possibly like the version of the WPI lib could be a problem.
Oh, that could be it. Do you have the
So
updated?
basically, like the first thing that I tried was like the 2021 version. Then I tried the 2020, and now I'm trying the 2022 version to see if like any of those makes a difference.
Okay, that could be an issue. And from what version of WPI lib was the sample program, for example? So if you start again and reinstall with just the 2022 version, there should be a sample Romi program, which then could be used to upload and sort of eliminate that as a possibility of crossing the version.
Yeah, right now I'm creating a new project in the 2022 version.
Nice. So just to recapitulate, starting with the Romi itself, it's power, in this case, batteries, or on your robot, that would be 12-volt car-like heavy robot batteries. They need to be charged.
Yep, I'm using rechargeable batteries.
That's good. So I think that's probably okay. And then as we discussed, your Raspberry Pi is seated correctly, we hope. And the analog for that on your robot would be your Roborio, and your power system are all connected up correctly. And there are no shorts or unforeseen difficulties there. Then you also need to
just may take like a while for it to connect. It usually takes like a couple of minutes for it to connect to like its own internet, because you know how like the Romi robot has its own internet.
Oh, it's sort of sending out a broadcast and figuring out how to connect.
Yeah, so like it takes a couple of minutes for like the internet connection to actually fully connect, like
Good.
for it to like upload its own internet.
As you mentioned that, then it's likely that at least the Raspberry Pi is getting some power as it's able to connect and take a software upload. So then we go onto the software as we looked through the sample Romi code, making sure it's from the right version of WPI lib, and then making sure you have the right motor controllers on the right channels.
I just realized the internet connection does not actually grant me internet. like proper internet. It only grants me like connection to the robot, not to
Exactly.
the actual internet. So I'm gonna try I'm gonna try just like, should I join like this meeting on my phone just so that I
Yeah.
can continue talking to
Good.
you while I'm connecting to the internet?
Sure. And that's a frequent thing as well. We encounter that as well. If you have to upload something or you have to look up something on the computer that you're using to connect to your robot, that's not easy. And that happens all the time. So you may want to have one computer for uploading code and another just for controlling your robot. That can really save a lot of time, as Ryan has just pointed out here. Then the, oh, here we are, admit. So we'll see if we, oh yeah, we're gonna get echo with Ryan unless you turn off one of your audio systems. There we are.
Is that better?
So yeah, now I can hear that. So when you went to actually operate your Romy, is there a particular palette command that you're using? Because it sounds like you're
So like what I'm doing is I'm just like running it normally.
okay.
Like I just like press like the run button.
Oh, okay. So you're not trying it on a driver station, for example?
I'm like, how would you actually like try like running the code on a driver station? That's like what I'm trying to figure out.
Oh, I see. I see. Okay.
So like what I do is I just like run the program just like any I just press like the run WPI desktop debug.
I see. Okay. Well, that could be a part of the issue.
So like how should I run it using driver station?
Yes.
Do you know how to do that?
Yes. The only thing is I may not have installed on this computer. So that's something I could see if I can install. There is a version for Linux that you can use. And meanwhile, you can try installing it on your computer. And then
I believe I have all the tools ready.
Oh, pardon?
I have all the tools ready. Yeah, I have FRC driver station installed.
Oh, you do. So maybe you could try pulling up your FRC driver station and see if it can connect to the Romy. That's how I assumed it was working, because they said it was very similar in operation to an FRC robot.
That's what I'm trying right now. So how do you enable it to the robot?
So can you share your screen? It would be very helpful, because this is something that happens all the time. There's so many things that can go challenging.
I'm just going to share my video.
Okay.
Since I'm on my phone.
Okay.
So basically,
I'll just share the screen here and see if I can make your video pinned. Let's see. Oops. Oh, no. Oh, yeah, I forgot. Everyone can see that. You can just pin the screen. There we are. Okay. Now, the first thing you want to do is make sure you have the right team number. It's in the settings, probably. The third button down on the left. Team number.
I'll say
06.
Oh, right.
4
numbers.
865, right? There it is. Good. Okay, so there's your team number. And now go to your USB.
Which one is that?
That's over down here. Right there. And there should be some kind of plugged in game controller that would show up there.
Oh, like, should I connect my game controller to Bluetooth now?
Yeah.
Okay. I'll go to settings. Paired. Keeps going from connected to not connected for some reason.
Oops. Oh,
Like
no.
it keeps flickering.
Is that possible that there's a battery issue with that?
I don't think so. Like I only just started using it like recently. I did not use it a lot because like I was just trying to figure out like all the WPI before I moved on to the Xbox controller.
I see. Okay, so that's another issue that may have to be sort of resolved. Oh, I'm not quite seeing here. Your camera came off, I guess.
Oh, I was just trying to see like if like one of the problems was that possibly like the controller was is like just like responding to like another device or something.
Okay. So, well, what I will suggest, you may want to do a few things to make sure that your game controller stays connected. And then once you've got your team number in there and you've got your game controller on the right channel, usually channel 0, then you should be able to run it under teleoperated or autonomous and get something going out of your Romy. That was how I was thinking it might happen.
Okay, so I guess that was my problem. I did not run it through driver station. I instead ran it off of like the place where we did our simulation.
Exactly. So I think that's the difference. Because in this case, running on the VS Code is going to execute it in your computer, but running it through the driver station is going to operate the code that's been uploaded into the Romy.
Okay.
So that's it.
Yeah, that was probably my problem.
Excellent. Well, hopefully that will work. Maybe you can update us next week and see if you got it working.
Yeah, I will.
Good. Well, thank you so much to everyone who joined us this evening, to all who are still here. If you have questions, please feel free to reach out by phone or email. I see, as Jad, you're here and have asked about joining a team. I wrote down your email address just in case you may want to email me in case I made a mistake on your email address, just so we can get in touch. And yeah, very much looking forward to your participation in the next few sessions, and very glad to respond to any requested topics. And we'll work together to have every team ready to operate their robots on the field. So
how'd you like this game this year?
It's really interesting. I didn't get to see the kickoff for the first time in a long time because we were handing out robots at Studica. But I just glanced over as they were showing the robots climbing up the rungs, and that was exciting. So I thought that was an interesting twist, climbing from bar to bar, which is kind of like the 2013 game, but I was like, wow, that was very interesting. And there's a kind of a trade-off. It seems that the 2020 game was how many balls could be shot at once. Like they were doing 9 or 10 balls at a time, some of the really great robots. Whereas this one, there's kind of a cycle time. You can only do 2 balls at a time. So you've got to kind of get them quickly offloaded and picked up again. So you have to consider that kind of stuff. So I thought that would be interesting. And yeah, there's definitely, it's always interesting when you have that sort of unknown element of robot contact. So like I remember 2016 game was very exciting because just when they're about to line up for the high goal and the tower, then the robot would get hit from the side. And I think similar
2016 was Stronghold, right?
Yeah, the Stronghold that happened. And then the 2018 game, I think that happened as well. So they're, or is that 2019? Keep on mixing them up now. But yeah, so there's some exciting elements from each of those years. I'm looking forward to that. But anyway, any game would be really exciting for me as long as we're on the field in March. That would be really great.
Yeah. Traffic is going to get very busy around the local.
Yes. So that's something to
our team was calling it a cornucopia.
Excellent. A reference to the Hunger Games, I see.
Yeah.
Oh no. Hopefully with a slightly more gracious and professional approach.
It is. It's 100%.
Great. So, well, thank you very much again to everyone, and I look forward to seeing everyone very soon. And have a great evening. Really looking forward to the season.
Have a good evening.
Take care.